This is the second video for the 1-1B lesson. We have 3 more problems. There might be a couple spots throughout this that if you feel like you can do the rest of the problem, I would suggest pausing the video and finishing the problem and then playing the video or fast forwarding the video to check your answers. Just like the first page, they're on a lot of these going to define the variables for us. These are definitely not at the rigor level or difficulty level that Math A Honors was or that Math B Honors will be at. So please don't get the wrong idea, but let's just practice good skills and just think globally about some of the things math-wise that will set us up to be successful as these problems get more challenging, because they will get more challenging quite quickly. In the NBA, the length of the basketball court is 44 feet longer than the width. The width of the court is W. So you don't have to sketch a picture. It is optional for a perimeter problem. And A says identify the unknown quantities, write an expression that represents the perimeter and simplify the expression. And then B, if the width is 50, what is the total perimeter? So thinking back, a rectangle has width and length. Frankly, doesn't matter which one's which, but the equal or congruent side should be across from one another. And so there are a couple of perimeter formulas. There's this one. Just add up all the sides. There's this one, 2L plus 2W. And then there's also this one, which is 2 times the quantity L plus W. In fact, I didn't really mean for it to work out this way, but it's kind of cool that if you distribute this one, you'll get this one. And if you expand this one, you'll get that one. So you can see that you can move between these. So we're going to pick one of those to use. So we already know that W equals the width of the court. And it says up here that the length of the basketball court is 44 feet longer than the width. So W plus 44 equals the length of the court. I've talked about how the variable should be in front when you have a linear expression. If you are doing a let statement, these are let statements, although I didn't write the let word. It doesn't matter if the number is in front. But for a simplified answer, we want number and then variable and then the number or the constant. All right, so we have 2 W plus 44. So I'm going to use 2L plus 2W plus 2 times W. All right. And then I'm going to simplify. 2 times W is 2W. 2 times 44 is 88. Plus 2W is 4W plus 88. And there is my simplified linear expression with variable in front and constant at the end. And then we are going to have W be 50. All right, and there shouldn't be anything too earth-shattering about these problems. Again, you should be ready for something more challenging, but also talking about practicing like writing a sentence, using a label, defining your variables. We had 2 variables, organizing your work vertically, or if you go horizontally, like I think I've already done, or I can in a second, separating by equal signs. Number 5. Peter is paid D dollars per hour for every hour he works over 40 hours per week. He's paid an additional $10 per hour. Peter worked 46 hours last week. So we have D equals D is the number of dollars or the amount that Peter is paid per hour. A, we're going to make a simplified expression, and B, if Peter's paid $12 per hour, how much money will he earn? I would suggest right now just pausing the video, thinking about this, maybe drafting an answer in pencil, and then unpausing the video and seeing how you did. Some think time is very important. You probably have not seen a problem like this in AH. I would start it. And these are called overtime problems. And I'll give you some time now to pause it and think about it, and then we'll talk about what this is, how to do this. All right, so you hopefully thought for a minute or two about this. And so we notice that there's actually two pay scales here. There's D, and then there's also D plus 10, which is Peter's overtime pay. Overtime meaning that after 40 hours, he gets a different pay of actually, he gets paid more. Some places they'll talk about time and a half, where if you get paid $10, time and a half would be you get paid $15. Essentially, you're going to multiply this by 1.5 or 1.5 time and a half or 1.5. In this case, it's just increased by 10. All right, so the easier part to this is that 40 hours are at the D rate and 6 hours are at the D plus 10 rate. Now, there are other versions of this expression, and how do you know if yours is equivalent to this one? Well, when you simplify it, assuming you don't break any rules of mathematics, if you simplify yours and you get 46D plus 60, then your starting one was good. And then we're going to plug in 12. Again, you can use a calculator. You should know how to do this, but I would also encourage that you do use a calculator. And we'll write our sentence. Peter earned $612. So we're doing a review of very simple word problems, of types of word problems. We've seen in overtime. We've seen perimeter. We saw buying stuff at a store. And the last one is one that you hopefully saw in 7th grade as well, which is a coin problem or a variation of a coin problem. Molly has nickels, dimes, and quarters in her piggy bank. She has twice as many nickels as quarters and 15 more dimes than quarters. Molly has Q amount of quarters. So Q is the number of quarters. She has twice as many nickels as quarters. So twice as many nickels as quarters. It sounds like there are more nickels, which would mean that I need to double the quarters to make them equal. I need to double the one that there's less of to make these equal. Even though this is a let statement, it's almost like an equation. We're saying 2Q equals N. And if there's more N's or nickels, we need to double the one that there's less of. Not to mention, we're probably doubling the one that is the let statement. And then the same thing for dimes and quarters. 15 more dimes than quarters, so there's more dimes, which means I need to add 15 to the quarters to set these equal. All right, and now we're going to find an expression that represents the total number of coins, number or quantity of coins, and it says nothing about the value. So it's just Q plus 2Q plus Q plus 15. There's not any earth-shattering math here, but it is talking about like grouping symbols. This is helpful, but not required. So we technically don't need these. I don't need you to do them. And frankly, we would drop these to start to combine this. So 1q plus 2q is 3q plus 1q is 4q plus 15. And there is our simplified expression. If Molly has 22 quarters in her piggy bank, how many nickels and dimes does she have? So nickels was 2 times 22, which is 44 nickels. And dimes was 22 plus 15, which is 37. So therefore, Molly has 44 nickels and 37 dimes. Complete sentence, optional to do a therefore statement, or excuse me, a therefore set of dots. How much money does Molly have in her piggy bank? Well, think back to coin problems in 7th grade. And we know that there is a little secret to this. You might even pause the video and try this. So what we're going to do is, if you've given this some thought and now unpause the video, is there is sort of this little secret, which you do know in the back of your mind. But the first time you saw a coin problem, you probably were like, oh yeah, that what we need to do is have the dollar amount for each coin. So 25 cents is going to be 4 quarters. 5 cents, 0.05, not 0.5, is 4 nickels. And 0.1 is 4 dimes. We don't need the 0 placeholder there. Well, actually, we already know what these values are. So I'm going to skip to the fact that this should be 0.25 times 22 plus, because we're building on part B, 0.05 times 44. So I can kind of just skip to this. And frankly, I could have just gone to this and ignored the previous expression. 37. That gets me 5.5 plus 2.2 plus 3.7 for a grand total of 11.4. So Molly has $11.40 in her piggy bank. And I'm going to do a therefore dot there. You don't have to box your answer here. And so this is kind of a refresher after summer break, talking about some good math practices, reviewing some basics of how to simplify expressions, and then we will build on this as we get to some of the other lessons in the module. I would suggest starring any problems that felt tricky. Maybe it was the coin problem. This might differ person to person. Maybe it was the overtime, that was new. Maybe it was perimeter. You should have seen a lot of those last year. Maybe it was this buying baby items, going to the movies and buying stuff, having money, and then taking away from that based on what was purchased. And then this one was similar to number 2, but dealt with earning money.